Welcome to Chapter 21. This chapter, we're going to look at chemical reactions. In Section 1, we'll look at chemical changes, and we'll get started right now. Chemical reactions are taking place all around you and even within you. You go home, eat supper, and that food enters your systems and processed by your body, turns it into energy. Chemical reactions, many chemical reactions occur. And a chemical reaction is a change in which one or more substances are converted into new substances. For example, you eat your supper, you can't get that original steak or chicken or French fries, whatever you had. After your body processes, you can't get it back. Similar to baking a cake, occurs when you bake a cake. You put in the liquid products, you bake it. You can't get those liquid products back because they've undergone a chemical reaction. In a chemical reaction, the substances that react are called reactants. The new substances produced are called products. And the relationship between reactants and products is written like this, where this arrow, let me pick a better color here. There we go. That arrow, what that represents is that the reactants produce the products or give the products. When reactants react, this is what results, the products. Okay, reactants and products. The French chemist Antoine Lavoisier established that the total mass of the products always equals the total mass of the reactants. And his name should be familiar to you because we saw him in our Einstein video. One of the early, wasn't actually a chemist, but he was the tax man with the wife, and he lost his head eventually during the French Revolution. A lot of his experiments he was looking at, he saw that the reactants produced products and the mass wasn't lost. One of his experiments, and that's depicted here, you can see in the picture, he burned a candle and he recorded the mass of the burning candle, and after it burned, guess what? It had the same mass once the candle went out. Lavoisier also experimented with mercury. He placed a carefully measured mass of solid mercury 2 oxide. Remember that oxidation number 2 from the last chapter? There it is again. Which he knew as mercury calyx in a sealed container. When he heated the container, he noted a dramatic change. The red powder that he started with turned into a silvery liquid, and he recognized that as mercury metal, and it also produced a gas. He determined the mass of the liquid mercury and the gas inside his contraption. Their combined masses were exactly the same as the mass of the red powder he had started with. He also established that the gas produced by heating the mercury 2 oxide, which he called oxygen, was a component of air. He's known as the father of modern chemistry. Good test question there. Lavoisier is known today as the father of modern chemistry for his more accurate explanation of the law of conservation of mass, and for describing a common type of chemical reaction called combustion. You know combustion as burning. Lavoisier developed a system of naming substances based on their composition that we still use today. Writing equations. Scientists have developed a shorthand method to describe chemical reactions. A chemical equation is a way to describe a chemical reaction using chemical formulas and other symbols. Some of the symbols you should become familiar with are depicted in the graphic on the right here. We've got a dot, and you might know this one from your math classes. Same symbol, it means produces or forms. Okay. Then we have actually I guess this should be a plus sign. We have solid, liquid, gas. This one you may not be familiar with, aqueous, and as it says, it means a substance dissolved in water. This symbol, heat, let me see that. Above that dot from up here, means that this reaction takes place in the presence of heat. That you have to add heat to the experiment or to the equation. Same thing for light, same thing for electricity. Metals in the atmosphere. When iron is exposed to air and moisture, it corrodes or rusts, forming hydrated iron. Oh, there's one of those oxidation numbers again. Iron 3 oxide. Rust can seriously damage iron structures because it crumbles and exposes more iron to the air. And again, when something rusts, a chemical reaction takes place because you cannot get the original iron back. Aluminum also reacts with oxygen in the air to form aluminum oxide. Unlike rust, though, aluminum oxide adheres or sticks to the aluminum surface, forming an extremely thin layer that protects the aluminum from further attack. And, of course, another metal that you're all aware of is copper. Okay, copper, and we went over this in the last chapter, forms a blue-green coating called a patina, and it actually protects the metal underneath it. Question number 1. That's the end of the lecture for section 1. Question number 1. What is a chemical reaction? And the answer is, a chemical reaction is a process in which one or more substances changes into new substances. Remember I said, if you can't get the original product back, it has undergone a chemical reaction. Question 2. The principle that the total starting mass of all reactants equals the total final mass of all products is known as the law of conservation of mass. During a chemical change, matter can neither be created nor destroyed. And question 3. Question 3 says, describe the products in the following reaction. We've got nickel chloride, and there's that aqueous symbol, means it's dissolved in water, plus 2 parts, 2 sodium hydroxide, also aqueous, and it produces, is what that arrow stands for, nickel oxide in a solid state, that's what that S stands for, plus 2 sodium chloride parts in an aqueous solution. It means they're dissolved in water. So the question asks you to describe the products in the following reaction. Get to act, and these are the reactants. Excuse me, this side, reactants, and over here we've got products, the solid and the aqueous solution of salt. So the correct answer would be letter D. You can look at it here. Products are solid nickel 2 hydroxide and aqueous sodium chloride. And this concludes the lecture for chapter 21, section 1.